Today is the first data science incubator about, well, not the first about testing, but the first in a series about testing. We have kind of touched on the topic of testing before, but lately I think we have kind of more a renewed interest in testing, and also some more experience, like more and more people at 2 degrees are actually testing their code in an automated way, which is the focus of this series. And I make this distinction because, anyone who writes code tests their code in a way just by looking at it and running it and on the console and seeing that you get what you expect. But the focus of this series is the automation of those tests so that you can run them very fast, very quickly, any number of times. So as usual in a series now we have an issue in the Data Science Incubator repository that explains basically what is the series about. We are focusing on just about anyone who writes a program that is not just a throwaway program, but something that you may want to use over and over again. I'm particularly focusing on programs that are worth testing because they are bigger than what we can hold in our head. So if the program is tiny, if it's just 1 or 2 lines, you very likely are not going to be bothering writing any tests whatsoever, because you just look at it, you know what's going on. But and if you change something, you kind of predict what's going to be affected in that code. But when the programs get more complex, it is important to start automating that process. And basically what you do is you turn every single click of your mouse into a line of code or some snippet of code. And the process is painful, but it's very rewarding in the long run, or not even in the long run, in the mid run, because when you run those tests over and over again, you save a ton of time by making them automatic. So basically, if you already know to write some code, in the beginning it's probably not so natural, but you get used to transforming those clicks, those mouse clicks, into lines of code, and that's just the art of that's just the process of actually writing automated tests. So why is this important? I really like not just this quote, but all the content about testing that appears in the book Mastering Shiny by Hadley Wickham. It includes a section about testing, which is the most up-to-date information about testing R code that he wrote. He also wrote a chapter called Testing in the book R Packages, which seems like a better fit, but now he's kind of working on this book about Mastering Shiny, and there is where the latest information about testing lives. So I'm going to be focusing on that one chapter that I'm quite familiar with. I've read it a few times already, and I think it's probably his best, more eloquent effort to succinctly explain what tests are, why they are important, and different levels of testing that we're going to be covering today. So today I wanted to mostly kind of introduce the series at a very high level. We are going to be covering this kind of why and what, but not so much how we actually do testing. In the next meetup, we are going to be getting into those kinds of details. But also I wanted to save some time at the end of today's meetup, which, by the way, I forgot to nominate a timekeeper. Jakob, could you be my timekeeper for today?
Sure.
Thank you. So please let me know, like 20 past. So we say 10 minutes for a little bit of a discussion. Hopefully the end of what I want to cover today will prompt some ideas and some questions. But also I would like to kind of ask you what you would like to get out of this series, because I have some ideas based on that book that I'm going to be following. But maybe your interest in testing is something beyond that book, and that's something that I would like to kind of discuss to see if we can adapt this series to include your interests, or if your interests are something specific that we should cover kind of more in a one-to-one session or in a different forum. The ds-incubator is kind of very general about best practices, and I aims to an audience that basically covers just about anyone at 2 degrees that writes any code, and even people beyond 2 degrees that might be interested in hearing what are our struggles and how we go through them. So in terms of what we are going to be covering, every series now has a syllabus. So that will, clicking on that link will take us to a new repo. So now each series has its own repository. This is something that maybe pollutes our organization a little bit. So that's something I would like to discuss later with Alex. If maybe it's a better idea to consolidate all the series into the ds-incubator repository, or if it's okay to kind of keep growing our number of repositories. But anyway, a side note, sorry. So this repository is the focus of, or is the house of the entire series. So far, all we have is a README file which explains what I'm saying right now. Today we're going to be covering this introduction, and the contents, as I said, come from the chapter, the introduction to the chapter testing. Then there are subsections that are going to be covered in different meetups in the future, at least 2 more meetups, maybe more. And apart from that introduction to the testing chapter, there is this subsection called philosophy that I would like to cover today, if we can. So the objectives of today, so in that introduction to testing, we are going to be covering these 3 first objectives. Basically, I think I already explained a little bit of why it is important to test, basically because we can't hold a lot of content of code in our brains so that we could predict if any change that we do affects any other part of the program. So as the programs grow, it is harder and harder to understand what is going to be the impact of any change, and thus we need to capture that in some automated form. So let's introduce the anatomy of the basic test. So this, if you are already familiar with, if you wrote any test before, you may already be familiar with this. So basically there is 3 components at least. First, a place where you declare, so this is that, sorry, by the way, we're going to be talking about testing, specifically R code, although this first introduction to testing covers testing at a more general level. So this particular subsection that I'm going right now is the only time where we're going to be talking specifically about how we test something, and it's just to give you like a gist of what's coming. And for many of us, this is something that we are already familiar with. So bear with me, we are going to come back to specifically how we write tests with the package testthat in other meetups. But for now, this is just an introduction. The basic anatomy of a testthat test. So testthat is an R package that allows you to write tests for your code. So the anatomy of a testthat test is like this. You don't need to pay too much attention to the details, but basically testthat has this function that is called test_that. And the first component is a place where you declare the intent of that test. This, is here just a string of text that, in this case, for example, the intent of this test, this is just a toy example, is to understand if as.vector, if the function as.vector strips the names of a vector. So the first component is where you declare the intent. A second component is where you generate some data. Sometimes the data comes from outside your script, your test script. You're reusing some data set that you have. But if you can, your data should be as small as possible, and sometimes just a toy fake data set as the one that we are creating here on the fly. The vector x now contains a first element called A that holds the number 1, and a second element called B that holds the number 2. That is all that we need in this particular test to see if the names A and the name B are stripped by the function as vector. We could be using a more complex data set, but there is no point. If we can do the same with less data and we can generate the data on the fly, showing it right into your eyeballs, then a lot better than having to rely on a data set that more obscurely comes from somewhere else, and then you have to kind of print that object to the console to see what the object is. So if you can, as simple as possible, as explicit as possible is the best. So recapping, first component is where you declare your intent, second component is the generation of your data, and at least the third component where you actually run what's called an expectation. An expectation is where you compare the output that you get after applying, in this case, the function as vector to the generated data. You compare the result from that to what you expect. So in this case, what I expect, or from this test, we expect that the result will be equal to the vector without the names. So the intent of this test is to check that this function strips the names, so the result should be the same vector but without the names. So this function expect equal comes from the testthat package again, and is the third element of a basic test. So again, as a final recap, first, you declare the intent. Second, you generate some data somehow, and third, you check your expectations basically by comparing your result, what you get from the code, with you compare that to what you actually expect. The book. Now we go back to talking a bit more generally about tests, and in this particular case, I'm talking about what you will find in that book, Mastering Shiny, in the chapter testing. The book covers 4 levels of testing, but in this series of meetups, we're going to be focusing on level 1 and level 4 a little bit. Because the book is about Shiny, and Shiny is an R package for building interactive applications. Then the book covers testing at these entire 4 levels. The level of the function, which is kind of the lowest level possible, the simplest level possible, where you can test that any feature that you build does exactly what you do, what you want it to do, what you expect it to do, at the very small, what's called unit level of testing. But then there's other ways in which you can, or what other aspects of your programs that you can test. And it makes sense in a Shiny app, for example, to test that reactive components do what you expect. Also, it makes sense to test that the behavior of your application on the web browser will behave as you expect. So that's the third element, JavaScript. And finally, that the visuals of your application are as you expect. The elements 2 and 3 are kind of quite specific to interactive applications. We are not covering those just now, maybe later in a different series if we do cover Shiny at some point. But the focus here is functions, because that is, to do any other level, you first need to go to the lower level. So functions, testing your code at the lowest level possible is always a must. So by showing you, or by discussing this in this series, we are going to be catering for the broadest of our audiences here. And visuals, it's quite tricky because, as you move down from 1 to 4, the tests become more real in a way, because basically you are kind of trying to reproduce more accurately the exact experience of a user, but also they become slower because those tests need to do more work, and also they become more fragile, and they can kind of throw a lot of false positives and make your life as a maintainer really difficult, because like tiny changes that may not be meaningful for a human will be detected by a computer and tell you, oh wow, there is a problem here. So like a small example could be, maybe in Mac or in Windows, the exact graph that you produce from a plot might be a little different because some color changed or some font didn't exist in one operative system and does exist in the other. So a test there would fail, but maybe it's not a real problem that you care about. So that's just an example of how, as you move from level 1 functions to level 4 visuals, the complexity of the issue becomes higher. But because I know that some people are already testing visuals, and I'm also kind of learning how to do that with the latest tools in testthat, I thought that, well, we would at least cover the basics of how you can do it, so you can try it and also learn from it, and also teach me what you find by doing that. So let's see. If possible, because of what I explained, because as you move from 1 to 4, the test becomes slower and more fragile. Whenever it is possible, you should strive to test your code at the lowest level possible, right? So always try to identify what is the minimum unit of behavior that you want to test, that you want to confirm that it's doing what you think it's doing, and focus on that if possible. Sometimes you can, sometimes you actually do want to test something like reactivity or like visuals, and then there is no other way to move higher in this natural hierarchy of testing. And what's interesting is that as you start testing your code, you will realize that your design changes, the way you write code changes. And why? Because once you start thinking about how you're going to be testing some code, that will affect the way you write your program so that you can easily test it, right? In some ways, code is easier to test than in other ways. For example, if you add certain parameters to your functions, to the interface of your function, so you can inject data or some, like a true or a false or whatever, then you can test, what will happen in different paths through your program with and without the parameter. If that parameter does not exist and instead you are relying on a global variable, on the global environment of the user, to reproduce that environment is a lot harder, right? So that's where I'm saying that the design of your programs is affected by your need to test in a simpler and easier way possible. So that is just about what I wanted to cover today. We still have a couple of minutes, and I will basically use those to touch on this idea of the testing philosophy and this idea of when you should write tests. And hopefully this will prompt the questions that I would like to hear about in the following 10 minutes. So Jacob, I'm aware that I'm 1 minute before I ask you to stop me. So I'm going to use that minute, maybe 2 minutes to discuss this. So Hadley, in his book, in the subsection testing, ends with a subsection called "When You Should Write Tests," and I think it's called philosophy actually. And basically, there is 3 times when you should probably write tests. They are not necessarily mutually exclusive. So the first that he mentioned is before you write code. This is not very intuitive, that you would first write a test and then write a program that does what the test is trying to test. But it is a super useful way to write code and to make sure that you just write the exact amount of code that you need, no more and no less, and that your program, as you write it, is fully covered by tests. So it's a very useful and very used way of writing code, but it's not always possible. Sometimes you don't know exactly what is the behavior of the function they are writing, and then you can't just write the test because you're still figuring out what you want to write. But when you do know what is the exact behavior of your function, then tests first, or what's called test-driven development, is a very good option. And getting into it can be very good in terms of how the design of your programs turn out to be. Second is after you write your code. So when you're figuring out your program, you usually create either a mental list, or maybe you actually take the effort of writing it down. You develop a list of worries about your program. So you write something and then you think, oh shoot, but what would happen if the user, instead of plugging a data frame, they plug a vector that is not a data frame? Or what will happen if instead of a number, they plug a string of the number 1, but in the form of a literal string? So all those worries you accumulate sometimes when you are figuring out your program, and at the end, once you have a relatively stable version, you go through that list and test each of those worries, and maybe change your code a little bit to address those worries and to make your test pass. So that's the second scenario. And finally, when you find a bug, every single time you find a bug, it is best practice to capture that bug in a little reproducible example that you turn into a simple test case. And that will also help you avoid the bug to come back. It's horrible to fix the same bug more than once. So once you have identified the problem, you fixed it, you just write a test. So if ever that bug comes back, you will know and you will fix it before it is exposed to the public. So with that, I'm going to stop here. I would love to hear questions or comments about this meetup, but also about what's your vision, what would you like to cover in this series of meetups, and let's probably discuss if that's possible, or if that's beyond what I envision this meetup to be. So open the floor for the next 8 minutes. I think there's hand raised. I'm kind of a little cold, out of touch with this.
It's me.
Okay, go ahead. There you go.
It was me. Yeah, so obviously I'm interested in the testing visuals.
Mm-hmm.
And I found very interesting what you said, that it actually can make your code like more fragile.
Yeah.
So I would definitely be interested in like seeing that in action, or also maybe talking about when does it still make sense to test visuals, in the sense of like comparing actual output, and when maybe it doesn't, and what's then enough, like things like that.
Yeah. It's maybe because I know that you're working with this like right now. Maybe I would suggest you go a little bit ahead and kind of jump to that book. The section on testing visuals is just maybe 3-4 paragraphs that won't take a long time to read, and I will probably answer some of the questions that you may have in your mind right now. Apart from that, I don't have a lot of experience myself firsthand. I would also encourage you to test. For example, you have a Mac, I believe, right? You're using Macs.
Yeah.
So I'm using Linux here. So I'm curious to see, for example, I wrote a snapshot test yesterday, and I'm curious to see if the test passes in your computer, or because it's a Mac and I'm using a Linux, it has a different behavior. I expect not, but I do expect a difference when it's run on a Windows. So it would be great to ask our Windows users to run the same tests and see if that snapshot is identified as changed on a Windows, because it has a different line ending. Those are things that we are figuring out. I'm also learning about that. So I'm very open to hearing your feedback, so that I also learn to test visuals. Yeah. Any other question that we have here or comment? Yeah, go ahead.
I think CJ was first actually, so.
Okay, CJ.
Yeah, okay, so the visual testing, I think is quite interesting too. I've been fooling around a little bit with this myself. Just quickly, my impression is that normally in R, you're testing, like you export the graphic as a SVG, which then is like a textual representation, which is a lot easier to test for changes versus trying to get the same exact binary file or raster image is probably going to be a nightmare across platforms. It's a little heads up on that. That's the kind of stuff I've been struggling with recently. I was going to say, I feel like I'm the one, or I have been mostly pushing back, Maro, when you're saying like this test-driven developing, writing tests first. But contrary to that, I was going to make a suggestion, which a lot of times when I go to write a function, I write like pseudocode. So I write like, okay, I want to do this. Like it doesn't have the actual work code, but like line by line kind of the steps that I want to do. And I think that's also a like really good point to continue further. At the end of that, you say, do this, do this, do this. And at the end, like, okay, I want to return a data frame that has these columns, that does this thing, and meets this criteria. And tests can easily make, a test around those things to have this sort of like test-driven style programming, which I've pushed back against a lot. So that's just a thought.
Yeah. Actually, I think when I read, what was that? Code Complete 2, I think, by someone who worked in Microsoft for years. It's a very classic old book. I think probably it was developed even before basically test-driven development was invented, maybe, but it did it did explain, writing programs based on pseudocode first, and basically writing kind of an outline of what the program should do, and then filling that outline. And at the time I practiced that, I really liked it. So I think I do think it is a great way to write programs. I also think that test-driven development sometimes can be very useful, and I use it, not always, but when sometimes, yeah, I love it too. Very looking forward to exploring more about testing visuals and using your experience, DJ. Also curious to see how much of that has been implemented in the new version of testthat 3, which does include a tool. It's an external tool, but it's linked. There is a function called snapshot review that pops up from a different package, a tool that compares graphs, so allows you to see, if one dot changed, you can see it. So I'm curious to see how that compares with other tools that you have mentioned in PRs or issues. Looking forward to that. Jakov?
Yeah, just brief question about testing essentially an entire workflow, or more precisely, think about the partner workflow, for example. We're definitely not testing all functions just yet, but we did have a test that would basically look at, does the whole workflow produce at least the files that we would expect it to.
Yeah.
Is that something that we are only doing because we're not testing properly on the lower level, and we don't really care about that anymore once it's properly covered? Or would you still say that we should do that? And maybe also somewhat along those lines, if we do that, should we not have a certain set of test data sets that makes sense for the whole process? And if so, is there somehow like a reasonable or a halfway helpful guideline somewhere that one could look at to help come up with that? Or is that just like thinking about it very hard for a while, and then at some point it just pops up out of my brain and
Yeah.
will work for that?
Yeah, first, that gives me the opportunity to thank Alex for, leading the last couple of meetups, but particularly the last one, which kind of sets the scene for this series. I understand that you talk about different kinds of tests, and I want to kind of disclose that at least the focus for the series that I envision is specifically unit testing. But, I'm also open to expand the series if there is enough interest and enough people think it's useful to cover other aspects of testing. But yeah, I think answering your question, Jakob, anywhere you read about testing, usually it refers to unit testing, and it's such an integral part of the development process that it is. Testing has been around for a long time. Maybe in the last 20 years, people have already decided that it's the way to go. It's no question about that. It's like saying, well, the Earth is round, something like that. So the fact that we don't have tests for unit tests for a lot of our programs is kind of odd. So unfortunately, many of us have this experience where we jump into a project and it is the way it is, and we kind of maybe assume that that's the way things are or should be, but it's not. So the reason that sometimes we test the outside of the program, at more like as an what I would call an integration level test, but maybe Alex has a different term for that. That's kind of just the way we have, as much as we can do to test something at least, when we don't have lower level tests. And ideally, it would be great to have lower level tests, but also you don't want to go so low that you are testing implementation details that will very likely change. So the art of testing is precisely to know how much detail you need to test, because you don't want to have too many false positives, right? And to be changing all your program all the time, because then you kind of lose trust in your tests because they fail over time, and then you kind of lose energy. So we are running out of time. Maybe someone has a last question or comment, and we wrap up for next time. No, okay. Thank you very much. Maybe I will be looking forward to your ideas about what you would like to cover. I did write a few things on the syllabus, but it's kind of incomplete maybe. Also expecting you to provide some inputs about what you would like to hear. Iago comment actually does give me the kind of information that I need to see, what else we can cover. But on Slack, reach out on Slack, maybe on the coding channel or directly to me to see if there's anything else that you would like to cover in this series. Thank you very much for joining, and see you next time.